screen is visible to you, right?
Yes, sir.
Okay, so we'll revise what we studied till, and I'll start with a new part. So recap, just 1 minute, huh? I want to see what was the previous page number. 1 minute only. Maximum 1 minute is required. So online lecture per 225. Now it is 26. And today is 21, 22. Okay. So Fourier series expansion with arbitrary period 2n that we were studying. Okay, so it was like this. Suppose f of x is a periodic function of arbitrary period 2l, which is defined between x equal to 0 to 2l. Then Fourier series expansion is f of x equal to a naught by 2 plus summation a n cos of n pi x divided by L plus bn sine of n pi x divided by L. Okay. Where the Fourier coefficients, they are given by, they are like this. A naught equal to 1 upon L integration from 0 to 2L f of x dx. Then n was like this, 1 upon L integration from 0 to 2L f of x cos of n pi x divided by L dx, whereas bn was like this, 1 upon L integration from 0 to L f of x sine of n pi x divided by L dx. Okay. Then we have written Fourier series expansion for even function and odd function. I don't think it is required to write those expansions. So now I will write the three formulas, right? This is the first formula and two more formulas corresponding to the Fourier series expansion of even function and then Fourier series expansion of odd function. But those formulas when the period is arbitrary period 2L. Now let me consider the standard period. So Fourier series expansion with standard period 2 pi. 2 pi is the standard period. Why 2 pi is the standard period? We are considering our aim is to write a given function, given periodic function in terms of sin x and cos x. So sin x and cos x are the standard functions and their period is 2 pi. Therefore, it is considered standard period is 2 pi. Okay. So first part, Fourier series expansion. Okay, so write with me now. Write with me. First formula. Suppose f of x is periodic function of period 2 pi defined in x between 0 to 2 pi and satisfy Dirichlet's condition. Then Fourier series expansion is f of x equal to, then Fourier series expansion is f of x equal to a naught by 2 plus n equal to 1 to infinity. See the formula on the right side, this formula, sorry, left side. There you substitute L equal to pi, right? 2 pi equal to 2L, na? Arbitrary period is 2L and standard period is 2 pi. That is L equal to pi. Okay, consider this. Use L equal to pi. Therefore, an cos of nx, pi will cancel,
Yes.
plus bn
Sign
sine
of
of nx. Where write formula for a naught, and where a naught equal to
1 upon 2 pi.
yes 1 upon pi. It is not 2 pi.
Yes.
Then 0 to 2 pi f of x nx. Then that an equal to 1 upon pi 0 to 2 pi f of x cos of nx dx. Okay, bn equal to 1 upon pi 0 to 2 pi f of x sine of nx dx. Okay, I'll go to the next page. Can I change the page?
Yes, sir.
Okay,
Yes, sir.
so next is second. Right, Fourier series expansion of even function. Right now, suppose f of x is periodic function of period 2 pi defined in, now see the interval of definition should be like this, huh?
Minus
So
pi to
midpoint
pi.
of yes, midpoint of interval should be x equal to 0. And f of x is an even function. Then Fourier series expansion is f of x equal to a naught by 2 summation an cos of nx, and where formula of a naught, yes, what is a naught, what is the coefficient?
1
It
by
is 2
2
by
l.
pi, 2 by pi, huh?
2 by pi.
And we have
2
to
by
consider interval
0
half
to
of
pi.
the whatever interval. Yes, 0 to pi. It is not minus pi to plus pi, 0 to pi, and therefore
F of
coefficient
x.
is 2. And hope everyone remember the concept.
f of x cos x cos n
Cos
by
of
x.
nx.
Cos nx dx, absolutely. Next, read on. Right, Fourier series expansion of odd function. Right now, suppose f of x is periodic function of period 2 pi defined in x between minus pi to plus pi, and f of x is an odd function. Fourier series expansion is. And this Fourier series expansion of odd function is very important when we want to solve the partial differential equation. Unfortunately, for the computer engineering, this is not part of your M3. But as a computer engineering, for you, discrete mathematics is very important. And a separate course is there in the second year on the discrete mathematics. So those who are good in mathematics, they can do research in artificial intelligence and machine learning. Mathematics is a very crucial part, and it is seen that the mathematics people, those who have done their PhD or done MSc in mathematics, they are unaware of the other things required for the machine learning, the computer related, software related things. They are unaware of that. Whereas the computer engineers, they are unaware of the mathematics very well. I'm saying, I'm not saying they are unaware of mathematics. They know mathematics, but more than sufficient mathematics is required if you want to do research or if you want to designing in the this artificial intelligence field. So it will be my suggestion. Those who are interested, they should start preparation of the ML from now only. And mathematics, for that, the base of mathematics should be very strong. Okay, no problem. We'll go through examples now. Examples. Let me change the page. So we have three formulas. Formula number 1, 2, 3, corresponding to the general Fourier series expansion when function is neither even nor odd. And when function is even or odd, we know what the procedure is. Yes, we'll start with different examples. Find Fourier series expansion of f of x equal to can anyone tell me why this last statement is given? This mathematical equation is given. What is the meaning of this?
Periodic.
Period.
Very good. It is periodic function of period 2 pi. Okay, usually it is given separately, but if it is not given, then you have to consider period as 2 pi or whatever the interval given. From there we can find the arbitrary period if it is so. Okay, Srada, given, start solving the example. F of x equal to pi minus x square. Interval is very important. Midpoint.
0.
X equal to 0 and right.
E1 minus E1.
Absolutely, absolutely. Absolutely, no doubt. Mention this. The resultant is a
even function.
even function.
Even.
Okay. So, Fourier series expansion is cos nx only. It is not n pi x divided by L, since it is period is 2 pi, therefore. Now write down a naught equal to, try to find the a naught. Hope you remember the formulas.
Yes, sir. 2 by pi.
Yes, absolutely. Find it.
A naught is equal to 2 by 3 pi square.
Absolutely. So after simplification, we have 4 by 3, isn't it? 4 by 3?
Oh, yes, sir.
Yes,
Sorry.
sir. 4 by 3 pi
Yes,
square.
sir. 4 by
4
3.
by 3 pi square.
Yes, sir.
Yes, absolutely. Those who are not getting this answer, check it, see where you are making mistake. Then there are next.
N.
Yes, an. So we have to use Bernoulli's formula.
UV formula. Yes, sir.
Yes, UV formula. So right up to this step, and then let me change the page. Those who understood, go through the remaining part and see what the Bn is. Sorry, An is. Okay, so I'll change the page now. Yes, use this formula. So using this formula, we have pi square minus x square integration of cos.
Sir, 8 pi upon n square. Is it answer?
Just 1 minute. No, it is not like that. Minus 1 raised to something is there. Might be while doing the substitution of upper and lower limit, you might have made a mistake. Check it once again.
8 into minus 1 raised to n upon n square.
8 you are getting. Why? I don't know why you are getting 8. I have a different answer.
8
We'll
means
check
4
it.
is sir.
Huh?
4 minus 1 raised to n by n
4 is
square.
there, correct.
Why?
upper limit pi. So it is like this. Pi square minus pi square 0. Lower limit 0, 0, sine of 0, 0.
minus 1 raised to n.
Absolutely.
0.
Yes. So only one term is non-zero. Remaining all terms are 0 only.
Or 4 into minus 1 raised to n.
That is okay.
Sir, sorry, minus.
Pi will cancel. Can keep answer as it is, or you
Yes,
can
sir.
write in this way. Can consider minus sign inside. Both of them are correct only. So answer is like this. I think A naught was 4 by 3 pi square. 4 by 3 pi square. This is the answer. This is the Fourier series expansion. Next, it may be asked from this series to find sum of few of the series. Okay, we'll try to understand it. Written the final answer.
Yes, sir.
Yes, sir.
Okay. Let me change it. Right on the next page, page number 30. F of x equal to so f of x is
Pi square minus x square.
now take n equal to 1.
1 by 1 square. It is a cos n x.
N equal to 2. N equal to 3. N equal to 4. n equal to 5. Substitute x equal to, students, see what result we are getting.
Pi square by 3.
pi square. Yes.
Cos of 0 is 1, so 1 upon 1 square, 1 upon 2 square,
Pi square by 12.
correct. 3 pi square minus 2 pi square, so pi square by 3, so pi square by 12, correct. Take 4 to other side. Next, right. Take x equal to pi, see what is happening.
Minus 2
इसका
pi
negative
square
आएगा.
by 12.
No, first cos pi, na? So I'll use this result. Whereas cos of 2 pi, 4 pi, 6 pi, they are equal to plus 1. Use these results. So cos of pi minus 1, and now so on. So minus minus sign will cancel. Is it like this? Let's see. Add 1 and 2. Is it like this? Plus minus will cancel. So in this way, we can find sum of infinite series using the Fourier series expansion. Clear? Understood? Can I go to the next page?
So just a sec.
So. Done?
Done, sir.
Okay, done. Fine. Fourier series expansion of f of x equal to yes, right. Solution.
Odd function.
Absolutely.
Bn, only Bn term will come. No?
Absolutely.
Fine.
So first let's simplify this. So write B and now Now use the UV formula once again. But we have to use UV formula twice for both the integrals. So for the first integral, it is like this.
Sir, 1 by pi will come, na?
Final answer. Acha, sorry, this should be 1 by pi, no doubt. This is first integral, second integral,
So in first integral, it will come minus sin n plus 1, na?
yes sir,
So
माइनस आएगा ना,
sign
माइनस
sign के
माइनस प्लस हो जाएगा फिर.
yes, no doubt. And then limit 0 to pi. I'll write remaining part on the next page.
Just a second.
No. Can I change the page?
No, sir.
Okay, no problem. Complete.
Done, sir.
Okay. Cos of n plus 1x divided by n plus 1 plus zero to pi. These are the limits. Substitute the upper limit. So like this. Upper limit pi. X equal to 0. Sine of 0, 0. plus this is first limit. Second is minus lower limit.
0, 0.
Yes. Using sign of n minus 1 pi 0. Therefore, these terms will become 0.
Sir, answer is 2n bracket मध्ये -1 raised to n upon n square minus 1 square.
2 minus 1 raised to n divided by n square minus 1 ना?
म्हणजे 2n bracket मध्ये -1 raised to n upon n square minus 1 square.
बरोबर. Correct. Correct. Absolutely correct. Very good. So 1 upon pi minus pi minus 1 raised to n plus 1 divided by n plus 1. Remaining all terms are 0. Remaining all terms are 0. So this pi will cancel. Pi will cancel. But so both are same only. Also, instead of that, better to consider in this way. Both are same only. No need to consider this. So we have read it here. This was AN, I think.
Sir, BN. It was a BN.
BN.
BN, BN.
Sorry, BN. So BN equal to minus minus sign will cancel. Are we getting 2n somewhere?
Yes, sir.
Or one is positive and other is negative?
से 2n ही आएगा।
2n ही आएगा वहाँ पे।
2n
2n
upon n square minus 1 आएगा.
2n is there, na?
Numerator 1 get cancelled.
Yes, sir.
Substituting values in 1. 1 was like this. Check it once again. If any mistake is there, please let me know.
No, sir.
Whatever answer I have not there, I don't have this n. Why, I don't know. Okay.
सर
हाँ.
n की वैल्यू 2 से स्टार्ट होगी ना समीशन में n की वैल्यू?
Absolutely. Very good. So in front of this, write down for n equal to or greater than 2. That is, if n equal to 1, we have 0 in denominator, na?
Yes, sir.
yes
Yes.
sir,
So
yes.
that is not valid for n equal to 1. So we have to obtain it for n equal to 1 also. Okay. Actually, instead of writing this part, na, here only we should write this. N greater than 2. Here only. Greater than or equal to 2. And then, please, on next page we have to write the remaining things. Thank you. Then on the next page, right up to this step. Okay, can I change the page? So if you substitute n equal to 1, we are getting bn equal to infinity, which is not valid. Okay, therefore we have to find b1 separately. I'll change the page. Hope we remember what the bn we written before some time. On the page number 31, it is written. Substitute n equal to 1. And let me make smaller rearrangement. Can I write it directly? Derivative of x is 1. Derivative of sine is minus cos, again minus sine. Upper limit. dn we obtained on the last page. 2n for n greater than or equal to 2. So we want to write it in this way. This is actual Fourier series expansion. Next, add on. Fast complete this. Complete the example. Written? Good again.
Yes, sir.
Yes, sir.
Can we go through one more example, or should we stop here?
Sir.
Stop.
Stop.
Yes, sir.
No problem. Okay, no any problem. Let me take attendance only. Then we'll stop.
Sir, I
How
had a
many
doubt, sir.
students are? Just 1 minute. Let me see how many. 61 are there. So 5 students are absent. Okay. Our aim is to find these 5 students. Okay. What the doubt is?
Sir, why we took differently for n is equal to 1?
Simple na. See this formula. Visible na? Bn equal to 2n minus 1 raised to n divided by n square minus 1. Okay.
Yes.
If it is n square plus 1, then we don't have any problem. Suppose I consider this formula for n equal to 1 also. Now substitute n equal to 1, you will get 2 minus 1 raised to 1 is minus 1. So in numerator we will get minus 2. Whereas in denominator
Yes,
we will
sir.
get 0.
Yes,
Right?
sir.
No?
Yes, sir.
And that is equal to infinity, which is not valid in fact. We should get finite value. Therefore,
Yes.
it is clear that we should find B1 separately. Now, suppose it is n square minus 4. Getting what I'm saying? Suppose Bn
Yes,
equal
yes.
to, numerator is as it is and denominator n square minus 4. So it means that when n equal to 2, the formula is not valid. So this formula is valid for n equal to 1, n equal to 3, 4, 5 and so on, but not valid for n equal to 2. So we have to find B2 separately. As we obtain B1 here now, we have to find B2 separately. But usually this type of difficult examples, right? The example may be asked for B1 only, but usually difficult examples are not asked in our exam. But we should know the concept again. Exam value aside, okay? We should know the concept value, okay? Okay,
Yes,
let
sir.
me take attendance. Just 1 minute. Let me download the attendance. I'll check it afterwards. Stop recording.